90.2b4 exempt electrical installations used exclusively for signal processing, instrumentation, and communications purposes from the NEC requirements if the following conditions are met. Firstly, only qualified persons have access to the equipment, and secondly, the equipment is under the exclusive control of the agency operating it. Let's apply this to the rectifier installation. Based on the provided information, the following factors are relevant to determining whether the rectifier installation falls under NEC 90.2b4. Firstly, qualified access. The rectifier is located in a telephone central office, which typically has controlled access and is restricted to authorized personnel. Secondly, exclusive control. The phone company has exclusive control over the operation and maintenance of the rectifier and its associated equipment. Thirdly, signal processing. The rectifier converts alternating current input to direct current power, which is used for powering telephone equipment and signal processing. Based on these factors, it appears that the rectifier installation meets the conditions of NEC 90.2b4. Firstly, only qualified persons have access to the equipment. Secondly, it is under the exclusive control of the operating agency, which is the phone company. And thirdly, its primary function is signal processing, specifically power conversion. Therefore, it is reasonable to argue that the rectifier installation falls within the exemption of NEC 90.2b4. This would mean that it is not subject to the general requirements of the NEC, such as grounding and bonding. However, it is important to note that some authorities having jurisdiction, also known as AHJ, may still require certain aspects of NEC compliance, such as grounding and bonding, even for installations that meet the conditions of NEC 90.2b4. In this case, the phone company and the AHJ should work together to find a mutually acceptable solution. Let's further break down the key elements of NEC 90.2b4 and how they relate to a typical telephone central office rectifier installation. We will cover the meaning of qualified persons, exclusive control, and signal processing in more detail. Firstly, qualified persons. The NEC does not explicitly define qualified persons in section 90.2b4. However, the NEC generally defines a qualified person as one who has the skills and knowledge related to the construction and operation of the electrical equipment and installations and has received safety training to recognize and avoid the hazards involved. In the context of a telephone central office, qualified persons typically include trained technicians and engineers employed by the phone company or its contractors. These individuals have the necessary expertise to install, maintain, and repair the rectifier equipment safely and effectively. Access control is a critical aspect of ensuring that only qualified persons have access to the equipment. Telephone central offices typically have security measures in place, such as locked doors, restricted access badges, and surveillance systems to prevent unauthorized personnel from entering the facility. Secondly, exclusive control. Exclusive control means that the phone company has the sole authority and responsibility for the operation and maintenance of the rectifier equipment. This includes tasks such as starting and stopping the equipment, adjusting settings, performing routine maintenance, and troubleshooting problems. The phone company also has the authority to decide when and how the equipment is upgraded or replaced. Exclusive control is typically established through company policies, procedures, and contracts. The phone company's control over the equipment is not shared with any other entity, such as the building owner or another tenant. Thirdly, signal processing. Signal processing refers to the manipulation of electrical signals to transmit information or control equipment. In the case of a rectifier installation, the primary function of the rectifier is to convert alternating current power from the utility grid into direct current power that is used to power telephone equipment and other electronic devices. This conversion of alternating current to direct current is considered a form of signal processing because it changes the characteristics of the electrical signal. The direct current power produced by the rectifier is used to power a variety of equipment in the telephone central office, including telephone switches, routers, servers, and other communication devices. This equipment relies on a stable and reliable source of direct current power to operate properly. Now let's consider some additional factors that may influence the application of NEC 90.2b4. Firstly, local amendments. Some jurisdictions may have amended NEC 90.2b4 or added additional requirements that apply to rectifier installations. It is important to check with the local authority having jurisdiction, also known as the AHJ, to determine if any such amendments or requirements exist. Secondly, equipment listing. The NEC requires that electrical equipment be listed by a recognized testing laboratory, such as Underwriters Laboratories, also known as UL, or Electrical Testing Laboratories, also known as ETL. However, NEC 90.2b4 may not require equipment listing for installations that meet the exemption criteria. However, some AHJ may still require equipment listing for safety reasons. Thirdly, grounding and bonding. Grounding and bonding are important safety measures that help to prevent electrical shock and fire hazards. The NEC has specific requirements for grounding and bonding electrical systems. While NEC 90.2b4 may exempt rectifier installations from some of these requirements, some AHJ may still require grounding and bonding for safety reasons. Here are some steps that can be taken to resolve disagreements between the phone company and the authority having jurisdiction, also known as the AHJ. Firstly, communication. The phone company and the authority having jurisdiction, also known as the AHJ, should communicate openly and honestly with each other to understand each other's perspectives. Secondly, negotiation. The phone company and the authority having jurisdiction, also known as the AHJ, should be willing to negotiate and compromise to find a mutually acceptable solution. Thirdly, documentation. The phone company should provide the authority having jurisdiction, also known as the AHJ, with documentation that supports its claim that the rectifier installation meets the conditions of NEC 90.2b4. Fourthly, third-party opinion. If the phone company and the authority having jurisdiction, also known as the AHJ, cannot reach an agreement, they may consider seeking a third-party opinion from a qualified electrical engineer or consultant. Let's consider a practical example of how NEC 90.2b4 might apply to a specific rectifier installation. Imagine a telephone central office that has a -48 volts direct current rectifier system that powers the telephone switching equipment. The rectifier system consists of multiple rectifiers, batteries, and distribution panels. The system is located in a secured room that is accessible only to authorized personnel who have received specialized training in the operation and maintenance of the equipment. The phone company has a comprehensive maintenance program in place that includes regular inspections, testing, and repairs. The program is designed to ensure that the rectifier system operates safely and reliably. In this case, the rectifier installation likely meets the conditions of NEC 90.2b4 because firstly, only qualified persons have access to the equipment. Secondly, the phone company has exclusive control over the operation and maintenance of the equipment. And thirdly, the primary function of the equipment is signal processing, which involves converting alternating current to direct current to power the telephone switching equipment. Therefore, the rectifier installation may be exempt from some of the general requirements of the NEC, such as equipment listing and certain grounding and bonding requirements. However, the authority having jurisdiction, also known as the AHJ, may still require some level of compliance with the NEC for safety reasons. The phone company should work with the authority having jurisdiction, also known as the AHJ, to determine the appropriate level of compliance. Let's delve deeper into the technical aspects of rectifier installations and how they relate to NEC 90.2b4. We will discuss the different types of rectifiers, their operating principles, and the safety considerations associated with their use. Firstly, types of rectifiers. There are several different types of rectifiers commonly used in telephone central offices, including firstly, silicon-controlled rectifiers, secondly, switch-mode rectifiers, and thirdly, modular rectifiers. Silicon-controlled rectifiers are the oldest type of rectifier and are based on silicon-controlled rectifier technology. They are relatively simple and inexpensive, but they are also less efficient and less reliable than other types of rectifiers. Switch-mode rectifiers are more efficient and reliable than silicon-controlled rectifiers. They use high-frequency switching technology to convert alternating current to direct current. Modular rectifiers are a newer type of rectifier that is becoming increasingly popular. They consist of multiple small rectifier modules that can be added or removed as needed. This makes them very flexible and scalable. Secondly, operating principles. Rectifiers operate by converting alternating current voltage to direct current voltage. Alternating current voltage is a type of voltage that changes polarity over time. Direct current voltage is a type of voltage that has a constant polarity. Rectifiers use diodes or other semiconductor devices to allow current to flow in only one direction. This converts the alternating current voltage to a direct current voltage. The direct current voltage produced by the rectifier is then filtered to remove any remaining alternating current ripple. The filtered direct current voltage is then used to power telephone equipment and other electronic devices. Thirdly, safety considerations. Rectifier installations compose a number of safety hazards, including firstly, electrical shock, secondly, fire, and thirdly, battery explosion. Electrical shock can occur if someone comes into contact with live electrical parts. Fire can occur if the rectifier overheats or if there is a short circuit. Battery explosion can occur if the batteries are overcharged or if they are exposed to high temperatures. To prevent these hazards, it is important to follow all safety precautions when working on rectifier installations. These precautions include firstly, wearing appropriate personal protective equipment, such as gloves and safety glasses. Secondly, de-energizing the equipment before working on it. Thirdly, using properly insulated tools and equipment. And fourthly, following all manufacturer's instructions. Let's further examine the specific requirements of NEC 90.2b4 and how they relate to the design, installation, and maintenance of rectifier systems. Firstly, design considerations. When designing a rectifier system, it is important to consider the following factors. Firstly, the load requirements. Secondly, the input voltage. Thirdly, the output voltage. Fourthly, the efficiency. And fifthly, the reliability. The load requirements refer to the amount of direct current power that the system must provide. The input voltage refers to the alternating current voltage that is supplied to the rectifier. The output voltage refers to the direct current voltage that is produced by the rectifier. The efficiency refers to the amount of alternating current power that is converted into direct current power. The reliability refers to the ability of the system to operate continuously without failure. Secondly, installation considerations. When installing a rectifier system, it is important to follow all applicable codes and standards, including the NEC. It is also important to ensure that the equipment is properly grounded and bonded. The equipment should be installed in a location that is well ventilated and free from moisture and dust. Thirdly, maintenance considerations. Rectifier systems require regular maintenance to ensure that they operate safely and reliably. This maintenance includes firstly, inspecting the equipment for damage, secondly, cleaning the equipment, thirdly, testing the batteries, and fourthly, replacing any worn or damaged parts. The maintenance should be performed by qualified personnel who have been trained in the proper procedures. Let's discuss the role of the authority having jurisdiction, also known as the AHJ, in enforcing the NEC and interpreting NEC 90.2b4. The authority having jurisdiction, also known as the AHJ, is the local agency or individual that is responsible for enforcing the NEC. The authority having jurisdiction, also known as the AHJ, may be a city, county, or state government agency. The authority having jurisdiction, also known as the AHJ, has the authority to interpret the NEC and to make decisions about whether or not a particular installation meets the requirements of the NEC. The authority having jurisdiction, also known as the AHJ, also has the authority to inspect electrical installations and to issue permits for electrical work. When there is a disagreement between the phone company and the authority having jurisdiction, also known as the AHJ, about whether or not a particular rectifier installation meets the requirements of NEC 90.2b4, it is important to communicate openly and honestly with the authority having jurisdiction, also known as the AHJ. The phone company should provide the authority having jurisdiction, also known as the AHJ, with documentation that supports its claim that the installation meets the requirements of NEC 90.2b4. If the authority having jurisdiction, also known as the AHJ, is not satisfied with the documentation, it may request additional information or conduct an inspection of the installation. If the phone company and the authority having jurisdiction, also known as the AHA, cannot reach an agreement, they may consider seeking a third-party opinion from a qualified electrical engineer or consultant. Let's consider the impact of technology advancements on rectifier systems and NEC 90.2b4. As technology advances, rectifier systems are becoming more efficient, reliable, and compact. These advancements are also leading to changes in the NEC. For example, the NEC is now recognizing the use of modular rectifier systems, which are more flexible and scalable than traditional rectifier systems. The NEC is also addressing the use of new battery technologies, such as lithium-ion batteries, which are more energy-dense and have a longer lifespan than traditional lead-acid batteries. As technology continues to advance, it is important to stay up to date on the latest changes in the NEC and to ensure that rectifier installations are designed, installed, and maintained in accordance with the latest requirements. Let's explore some best practices for ensuring the safety and reliability of rectifier installations in telephone central offices. Firstly, design. Design the rectifier system to meet the specific load requirements of the telephone central office. Select equipment that is listed by a recognized testing laboratory, such as Underwriters Laboratories, also known as UL, or Electrical Testing Laboratories, also known as ETL. Ensure that the equipment is properly grounded and bonded. Install the equipment in a location that is well ventilated and free from moisture and dust. Secondly, installation. Follow all applicable codes and standards, including the NEC. Use qualified personnel to install the equipment. Inspect the installation to ensure that it is properly installed and that all connections are tight. Thirdly, maintenance. Perform regular maintenance on the rectifier system. This maintenance should include inspecting the equipment for damage, cleaning the equipment, testing the batteries, and replacing any worn or damaged parts. Keep records of all maintenance activities. Fourthly, training. Provide training to all personnel who work on or near rectifier systems. This training should include information on the hazards of electricity, the proper procedures for working on rectifier systems, and the use of personal protective equipment. By following these best practices, you can help to ensure the safety and reliability of rectifier installations in telephone central offices. We will now address common misconceptions about NEC 90.2b4 and rectifier installations. Firstly, misconception 1. NEC 90.2b4 exempts all electrical installations in telephone central offices from the requirements of the NEC. This is incorrect. NEC 90.2b4 only exempts electrical installations that are used exclusively for signal processing, instrumentation, and communications purposes and that meet the other requirements of NEC 90.2b4, such as qualified access and exclusive control. Secondly, misconception 2. If a rectifier installation meets the requirements of NEC 90.2b4, it is not necessary to ground and bond the equipment. This is also incorrect. Grounding and bonding are important safety measures that help to prevent electrical shock and fire hazards. While NEC 90.2b4 may exempt rectifier installations from some of the grounding and bonding requirements of the NEC, it is still important to ground and bond the equipment in accordance with good engineering practices. Thirdly, misconception 3. Only qualified electricians can work on rectifier installations. This is not always the case. While it is important to use qualified personnel to install and maintain rectifier systems, other personnel, such as telephone technicians, may also be able to perform some tasks such as inspecting the equipment and replacing batteries. However, all personnel who work on or near rectifier systems should be properly trained and should follow all safety precautions. By understanding these common misconceptions, you can help to ensure that rectifier installations are designed, installed, and maintained safely and in accordance with the NEC. Let's delve into real-world case studies of NEC 90.2b4 application to rectifier systems. We will analyze different scenarios and discuss the factors that influence the interpretation and enforcement of the code. Case study 1. A telephone central office installed a new rectifier system to power its switching equipment. The system was located in a secured room that was accessible only to authorized personnel. The phone company argued that the system was exempt from the requirements of the NEC under NEC 90.2b4. The authority having jurisdiction, also known as the AHJ, initially disagreed, arguing that the system was not used exclusively for signal processing. However, after further discussion, the authority having jurisdiction, also known as the AHJ, agreed that the system met the requirements of NEC 90.2b4 because the primary function of the system was to provide direct current power to the switching equipment, which was used for signal processing. Case study: to a telephone company installed a rectifier system in a remote cell tower site. The site was not accessible to the public, but it was not continuously monitored by qualified personnel. The authority having jurisdiction, also known as the AHJ, argued that the system did not meet the requirements of NEC 90.2b4 because it was not under the exclusive control of the phone company. The phone company argued that it had exclusive control over the system because it had a contract with a maintenance company to provide regular maintenance and repairs. The authority having jurisdiction, also known as the AHJ, eventually agreed that the system met the requirements of NEC 90.2b4 because the phone company had demonstrated that it had taken reasonable steps to ensure that the system was properly maintained and operated. Case study: 3. A telephone company installed a rectifier system in a customer's premises to power a private branch exchange. The authority having jurisdiction, also known as the AHJ, argued that the system did not meet the requirements of NEC 90.2b4 because it was not located in a telephone central office and was not under the exclusive control of the phone company. The phone company argued that the system was used exclusively for signal processing and that the customer had granted the phone company exclusive control over the system. The authority having jurisdiction, also known as the AHJ, eventually agreed that the system met the requirements of NEC 90.2b4 because the phone company had provided documentation demonstrating that the system was used exclusively for signal processing and that the customer had granted the phone company exclusive control over the system. These case studies illustrate the importance of carefully considering all of the factors that are relevant to NEC 90.2b4 when determining whether or not a particular rectifier installation is exempt from the requirements of the NEC. Let's explore the future trends in rectifier technology and their potential impact on NEC 90.2b4. As technology continues to advance, rectifier systems are becoming more efficient, reliable, and compact. These advancements are also leading to changes in the NEC. Some of the key trends in rectifier technology include: firstly, increased efficiency. Rectifier systems are becoming more efficient, which means that they consume less energy and produce less heat. This is due to the use of new semiconductor materials and advanced circuit designs. Secondly, improved reliability. Rectifier systems are becoming more reliable, which means that they are less likely to fail. This is due to the use of more robust components and improved manufacturing processes. Thirdly, smaller size. Rectifier systems are becoming smaller, which makes them easier to install and maintain. This is due to the use of surface mount technology and integrated circuits. Fourthly, smart rectifiers. Rectifier systems are becoming smarter, which means that they can monitor their own performance and communicate with other devices. This is due to the use of microprocessors and networking technologies. These trends are likely to have a significant impact on NEC 90.2b4. As rectifier systems become more efficient, reliable, and compact, they may become more widely used in applications that are currently covered by the NEC. This could lead to a re-evaluation of the scope of NEC 90.2b4 and the development of new requirements for rectifier installations. In conclusion, understanding NEC 90.2b4 is crucial for anyone involved in the design, installation, and maintenance of rectifier systems in telephone central offices. By carefully considering all of the factors that are relevant to NEC 90.2b4, you can help to ensure that rectifier installations are designed, installed, and maintained safely and in accordance with the NEC. Remember to always consult with the authority having jurisdiction, also known as the AHJ, to determine the specific requirements that apply to your particular installation. and stay up to date on the latest changes in the NEC and the latest advancements in rectifier technology.